All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well. I think we are live on both platforms, I believe. All right. So, it says my bit rate is low. All right. Hopefully that's not an issue. All right. Anyway, welcome everybody to the stream. I hope everybody is doing well. I am feeling much better. I know we were offline yesterday. We missed yesterday's stream. I was still sick and barely had gotten my voice back. Yeah, I'm over that now. I think for the most part, I have my voice back, at least mostly. So we're gonna see how things go tonight. If my voice wears out, I might have to end the stream early, but I think I'm gonna be okay. All right. Before we continue, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Alazaran. That is the highest tier of subscription over on Patreon/YouTube memberships. I would also like to thank our partners who are the tier below that. They are Gerbolis Inc. and Matt Osgard, as well as all of our supporters listed here under the supporter section. That is a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you guys very much for your support. It is greatly appreciated and helps me offset costs associated with running the channel, the website, costs associated with the project, things like that. So thank you guys for your support there. I also appreciate each and every one of you viewers, because without you guys and every one of you, this project would not exist. So thank you guys very much for being here, following along, whether you're doing it live or on the VOD. After the fact, thank you guys for being here. I appreciate you guys. All right. So, with that being said, Tammin, good to see you. How's it going? Apotham, good to see you as well as Smudge. Good to see you guys over on the Twitch side and over on the YouTube side. Mahmood, good to see you as well. Yeah, I see you're on a different account, but I recognize the name. From Lake, how's it going? Good to see you as well. Welcome, guys. All right, so what we have on the roster tonight is something that I hadn't quite planned on tackling yet, but I think we kind of need to, and we're going to go into the reasons why. Before we do that, though, I do want to just take a quick second and show you guys where we're at. So I did some work offline, did a lot of work offline, actually. And so one of the things that I wanted to work on, since we kind of missed some stuff, I wanted to at least catch up to move us forward, right? So I wasn't able to talk necessarily, which is why we didn't have the stream, but at least I could still code, right? Yeah, I'm definitely feeling much better tonight. Thank you. How are you and why are you? I appreciate that. Why am I? I don't know. That's a deep question. Way too deep for me right now. All right. So what we're looking at here is an updated version of what we saw last time. Now, I fully realize where we left off last time, so I'm going to take a minute and explain. So last time we were trying to generate track geometry, and we were just doing it linearly, and we were like most of the way there. We had some issues with segments lining up and things like that. All of that stuff has been resolved, as you can see. I've also taken the time to apply a material so that we can actually see a mapping of what the geometry looks like, as well as we actually have something new here that we didn't have before, which is sort of this little box or rectangle here that represents our vehicle, right? And so if I just switch to the editor perspective real quick, we can just take a look at some of these things. So these both have just a material, like a default material that I kind of set up, a test material, so that I can make sure that texture mapping is accurate and as it should be, right? And so we have this little box is what essentially represents our vehicle for now. Obviously, we'll be replacing that with some sort of mesh. And then we have the track, which the track is actually fully generated now. With some caveats, right? So what we're looking at here is you know what? Let me blow this up a little bit so you guys can see a little bit better. So what we're looking at here is essentially a track of that's built out of generated geometry. And so one of the reasons I chose this material is because it has a split right down the center of it, so that you can see where the actual center line of the track is. And I chose varying widths and coordinates on both sides on purpose, so that you could actually see how this stuff works, right? So this center line right here is actually the center point of the track all the way around. And so you can kind of see that even a little bit off in the distance there. And so what we're actually looking at here is we are looking at a track that is generated using Bezier curves. And I got those in and working as well. That actually wasn't too hard. We'll go over the code here in a minute. And so we actually have multiple segments in here. We talked about segments last time. And each of the segments are denoted by this thicker black line that's here. So this right here is the first segment. This here is the second segment, third, fourth, and so on. And you can see that they're of varying lengths. They all do have the same tessellation or number of slices, if you will, in between them. So you can see this one here is very densely populated because it's very close together. And some of these other ones are much more stretched out, right? And so we just wanted to get kind of a feel of what that might look like under those different various scenarios. So our geometry generation from our track is looking pretty good. I'm pretty happy with how this came along. If we go in here a little bit for a little bit of a closer view, you can actually see we have those heights in there working as well, although it's not too pronounced right here. You can kind of see it a little bit. I believe down this way it is a little bit more pronounced, where you can see that a little bit easier, right? And so you can kind of see how the center sort of dips down a little bit in space, right? And so we have that working. And if we actually just switch to wireframe view here, we can see what that generated geometry looks like. And indeed, it follows that center line as we kind of talked about before. So the goal with this was to have all of those individual segments be eventually frustum culled, right? So that we only generate segments that were actually visible to the camera. Eventually we'll have occlusion culling and things like that. So with that said, at least we have something in place to sort of handle that for now. All of the topology looks good. If we take a look at the lighting, it's mostly a flat track, so you can't really tell too much, but it does receive shadows. Here's what the normal view looks like, and I think that's not 100% correct. We might need a little bit of work there, but we're going to come back to that. And then of course this is the shadow map generation. So overall, we're looking pretty good. I even had it dip down into the water a little bit here, just kind of get an idea of what that might look like in terms of, it interacting with the water. So we have that. And then the second bit that I actually got working was I showed a little bit of this off camera before. So we obviously have a vehicle that moves around, or a box just for now, and we've got a following camera, right? And I'll show how we did that. Basically, all that is an offset from the back of the vehicle, and then up a little bit with a look-at matrix, right? So we have the ability to move around, and if you'll notice, we are actually sticking to the geometry of the track. So we go up and down as we move around. And you'll notice that, we can kind of slide along the edges here and things like that, right? Without, going through it and things like that. So, we've got the ability to sort of, very roughly navigate through here. And you'll see that there's some jitter here. And that's one of the things I want to talk about. Essentially the way that this is working is we are essentially constraining a single point in space to this track's geometry. That has its advantages and disadvantages, right? It's very simple to sort of constrain just a single point as opposed to something more complicated like a sphere or a box even, or even some sort of arbitrary geometry, right? This was very easy to get up and running, but it has its its benefits and its drawbacks, right? So the main benefit is I was able to actually piece this together and get it working pretty quickly. The drawback is we have some jitter, right? And that's for several reasons. And then also it's possible at certain joints to leak through the track, right? So I know that this actually is a point of contention right here. If I press against this long enough, we eventually go through it and our collision detection fails, right? And so the idea here was that we didn't want to allow the user to kind of go through the track. And as you can see, if you press it just right, you can kind of do that. And so, you know, advantages and disadvantages, right? But that is basically where we're at the moment. So, let me catch up on comments, and then I will, and then we'll continue. Singy, good to see you. Welcome. See, I'm curious, how do you handle the Japanese text rendering? I see you have it, but I meant, do you draw each glyph separately? Yes, we do for right now. So essentially, that works through our system text, is what we call it. And essentially what we do is we keep an atlas of the characters that are used for each font at each size. And whenever we have a new character that we run across that we need to render, we just add to that atlas. And so we're able to add anything that the font supports. And so we've got a font in here that supports Japanese, Chinese, and Korean text. And that's how we're handling that. So it's after that point, it's essentially treated the same as a bitmap font. So we just render the glyphs onto quads, and then we're done, right? I implemented Arabic text rendering, and my engine had troubles with performance because of the complicated shaping system. I think Japanese is similar. So Arabic is one of those languages that's super interesting to me to implement, and I am going to do it at some point, but I haven't yet because of the requirements of it, right? Because it has those bits that connect one character to the next, and they only exist between certain characters, and we don't have that functionality now. And also, we can't go right to left yet. That wouldn't be too difficult to actually achieve. We would basically just have to flip some of our logic to run backwards. But the connecting the glyphs and having extra sort of, I forget what they're called, ligatures maybe or something, that connects one character to the next, like as in Arabic, would be something that adds a little bit more complexity to the solution. So we haven't done that yet. I want to at some point, because obviously I want to localize to a lot of different languages, but we just haven't gotten there yet. But yeah, I'm totally familiar with what you mean. All right, let's see. Lazy Man, good to see you as well. Welcome. Feels weird seeing you work on the game after 2 years or so of engine development. Engine was only 2 years. No, the engine was almost 4 years, actually. Yeah, it was quite a long time. Now, granted, at first I didn't really work on it, and I kind of kept it on camera only, which slowed things down quite a bit. And also I can only work on it part time, right, at best. So, but yeah, it's been about 4 calendar years, but if I were to compress that into actual 4 full-time hours, we're probably more talking about 10 to 11 months of work at this point to get where we are. I love Arabic. Yeah, it's a beautiful, beautiful language for sure. As the subject is text, how do you handle text positioning? Like if you were to add more lines to text, do you keep track of where to write the line to write the next line of text? Yes, we actually have our objects actually handle that. Our text rendering objects actually handle that. So one example of that I have is in the debug console. The debug console actually is capable of doing that, and that's what we're looking at here. Is this is actually one text object with new line characters in it for all the logging. So this isn't like we have a separate control for each one of these lines. No, it's one control that actually does this, that does all the rendering. And it does it in multi-line, right? So, yeah. Do you recommend learning Vulkan over OpenGL? I drew my first triangle yesterday with OpenGL. Vulkan looks scary. So that depends on your experience. If you have not done graphics programming before, and if you have not done semi-serious systems programming, I would say start with OpenGL. Because Vulkan requires you to understand a whole heck of a lot more about memory management and asynchronous logic and even multi-threading stuff that technically you don't really have control over. But you have to think about. It requires you to understand a whole lot of that stuff and memory synchronization and all that stuff. I would say if you haven't dealt with any of that stuff yet, familiarize yourself with the concepts through OpenGL first. And then when you jump to Vulkan, you'll be like, oh, okay, I see how this translates to this. I hope that makes sense. Text rendering is actually kind of hard, at least for me. Depends on what you're doing with it, right? So in our case, we render out glyphs to a atlas, and then from there we just draw them to quads. We just essentially, texture map them to quads, and that's really all it is. And at that point, it's not very hard to set up. If you're talking about generating the glyphs from like a font file yourself, then yeah, that's a little bit harder. But most of the time, you don't really have to do that. Keep doing OpenGL for a while. Yeah, that's what I would say. Yeah, if you don't have a lot of experience with graphics programming in general, I would start with OpenGL, and then once you have a decent hold on that, and you've written a couple of different renderers that do 2D, or if you're interested, 3D. Once you've wrapped your mind around those concepts, then I would quickly switch to Vulkan, because Vulkan is the future, right? Or Vulkan style APIs are the future. DirectX 12 is that way. Metal is that way. That's kind of the way everything is going. So fun. I'm loving it. Yeah, that's how I feel about graphics programming too. Dr. Elliott, good to see you as well. How you doing? Let's see. Apotham, you switched over to YouTube. That's fair enough. Let's see. Okay. What graphics API did you start with? I started with OpenGL. Yep. Gosh, when did I start with OpenGL? Must have been like the first OpenGL work I did was maybe 2007 or 2008. I did some DirectX stuff around then too, and I kind of jumped back and forth on them because I was working on different projects. So it's a little bit hazy at this point. It's been a while. But yeah. You gave up on the DLL dream? Why? Don't do that. I'll take a look at the implementation. I want to do something similar to that console, but with GDI. That's fair enough. Yeah, the concepts should translate anyway. Okay, so let's talk a little bit about the implementation. I've got a to-do list here, and we'll get to that. I know you guys have seen the title of the stream, and we'll get to that too. But I want to talk a little bit about what is going on in the actual game code itself. So we added some stuff here. Most of the stuff exists in application update, right? The other part of it is, I guess I could show you guys the track scene. We did add a couple things in here. So one thing I did initially, because we don't have a concept of prefabs yet, is I actually configured our vehicle in the scene, right? So I set up a scene node called test vehicle with an Xform, and then it has a single child called the vehicle mesh. And that has an attachment that is the test cube that we have. I've set a scale on that and a position, all that stuff. And also obviously an asset name, right? So we actually have a cube asset for this we're using. And that's so we can easily swap it out, right? So why did I set it up this way? Why do we have this sort of test vehicle and then a vehicle mesh in here? Well, the test vehicle is what we actually move around. So the transform of this is what actually moves around in the world. And I wanted the vehicle mesh to be separately manipulatable. Manipulatable? Is that a word? I don't know. To be able to be manipulated separately. And so the reason for that is because we might think about it this way: if we've got like a hover bike or something, and we want to rotate in place, turn back and forth in place. Generally, that's going to involve some sort of grabbing the handlebars and like leaning right to the side. And so that's going to be a rotation, right? But we don't necessarily want to rotate the entire actual vehicle. Maybe we just want to rotate the mesh, right, and anything that's childed to that. So the physics will be tied to this guy, but we might have animations and other things going on that are sort of within that space. So it's much easier to apply that sort of rotation to the inner vehicle mesh than it would be to apply it here. So when we apply the physics, we apply the physics here, but any sort of additional animation we would apply here. And so that's the reason for that. And obviously this will have other stuff attached to it as we go. We could attach lights to it and all kinds of other stuff. And so all we do is we essentially grab a reference to this test vehicle and the vehicle mesh in our game. And we actually have those X forms saved off. So if we take a look here, actually, in the game state, we actually have the test vehicle X form and the test vehicle mesh X form. So we obtain references to that. And this allows us to do things like apply rotation and velocity, right? All kinds of that good stuff. So essentially what we do, the way that this works, is we have a velocity factor that is starts off at 0 every single time. We define a vehicle speed and a vehicle turn speed. And then for all of these different keys, we essentially say, well, first of all, if we're in the game mode world, in other words, we're playing the game, then we go ahead and say, well, if key W is pressed, then we want to add to the velocity in the forward direction, vehicle speed times delta time, right? So we're basically going to say we want to add velocity in the forward direction, right? As long as this key is held down. S, of course, does the opposite of that, just goes backwards. And then Q and E are more of a strafe, just direct left, direct right. And then A and D are responsible for rotating, right? So these four apply velocity directly, and then these two create a quaternion rotation and rotate the X form. After that, we want to actually make sure that the shape is constrained to the track. So what we do is we obtain the X form once again. We get the position from that, right? So the X form gives us a mat 4. We take that mat 4 and we extract the vehicle position from that. And then here we're doing some surface normal stuff. So I'll kind of come back to that. I'm going to skip it for now. But essentially what we do is we have this constrained track, right? So we pass it the vehicle's position, which is that outer transform position. We pass it the velocity that we built up here, which might be nothing, or it might be forward, backward, combination of, forward and left, who knows. And then we pass it a pointer to the track itself, and a pointer to surface normal to output, right? And so what this function does is it says, okay, based off of this vehicle's position and the velocity, this is where we want the vehicle to go. Can we actually do that? Yes or no? And if so, then go ahead and move that direction. And this essentially takes that, projects this position plus velocity onto the actual track itself, taking into account the edges, and we move the vehicle as far as it'll go. If we're along the side, it'll project that that vehicle position along that side vector, right? And that's how we get that sliding, right? If we're facing it directly, it basically does not allow us to go anywhere, right? So it only allows us to project along that edge as far as we can actually go. given that it actually makes sense to do so. And like I said, this logic is decent, but not all the way there yet. And then after all of those calculations are made, it constrains it to the track, meaning it doesn't allow it to move outside the track. And we are returned a new vehicle position that has taken the old vehicle position, the velocity, as well as the track, and constrained the results of all of that to that. And then we are presented with the final vehicle position. And then we go ahead and we set that position on the X form. And then the other thing that we do is, and I have a note in here that this doesn't seem to be working correctly. Obviously, we'll revisit this. But what I was doing was, we have all those triangles that are on the actual surface of the track. So what we do is the triangle that we're sitting on top of, we get the surface normal of that, and we say, hey, set the rotation of the vehicle, set it on the axis of that normal. Set the rotation there, so it should make it tilt, right? And we don't have this completely correct yet. And so we're going to have to look at that a little bit further to maybe figure that out. So that's what all that's doing. We reapply the vehicle transform and all that stuff. And then here is where we actually set up the follow camera. So the way that this works is we've set up a chase distance here. Obviously, that should be configurable, right? And even dynamic. But we've hard-coded one for now. We have a backwards offset, which basically says, okay, let's take the forward vector that we got before. So wherever that vehicle is facing, let's get the forward vector. And then take the negative chase distance and multiply that forward vector by it, which means backwards, right? So what that's going to do is it's going to take from the center point of the vehicle and move backwards that many units. And then we also have an upward offset that's applied right after that, right? So our upward offset is just 3 units up, right? So we go 10 units back from the forward vector, right? So backwards, and then up 3 units. And that is where the camera position is set. So we do a vector 3 add on that to get that, right? So we take the vehicle position, we add the backwards offset, and then we later add the upward offset. So we go back and then up. And then we set the camera position to that. And then we get the direction from the point to the focus object, right? Which is just a matter of getting a vector to that particular vehicle position, in this case, or whatever the focus object may be. We normalize that vector, and then we get the yaw and the pitch from it using arctangent to and asine, right? And so we just take these two, and then we turn that into Euler angles, which we then use to set the camera. I'm thinking at some point we're probably going to take the camera and convert it from Euler rotations to quaternions, like everything else in the system uses. But for now, we have to do this kind of hackery, right? We could have also used a projection matrix, or not a projection matrix, a look-at matrix to do this, but this was just kind of the way I did it. So this is what's responsible for setting the camera and making sure that it chases. Now, obviously, we would want to eventually tween this over time and have the chase camera basically interpolate to that position slowly over time so it's not so snappy back and forth, but we're not there yet. All right, so there's that, and I think that about covers it. So that is going to bring me to my next point, but I figure I should probably check chat before I go on to that. Gave up on the DLO dream. Too frustrating. Maybe I'll do half and half DLO plugins. Fair enough. I mean, yeah. The cursor got big. Yeah, so I switched to KDE Plasma for my desktop environment, and it does the Mac OS thing where if you shake the cursor, it makes it really big. It's supposed to be a thing like where the heck did my cursor go? Like if you have multiple monitors, you'd be like, where's my cursor? And you could just move it around really quickly and be able to find it very quickly like that. But I've actually found that it helps, me point things out to do that. So boomer things. Yeah, exactly. I'm a blind old man. Have you guys seen these freaking Coke bottles? I mean, it's ridiculous. Sukelos Music, how's it going? Good to see you. Welcome. Let's see. Hello, have you checked the release notes on Vulkan 1.4? Any useful stuff in your opinion? I have not actually looked into it yet. I've been meaning to, I just haven't had a chance to catch up on it. Part of the reason for that is because I know that 1.4 adoption is not going to be quick across a wide range of hardware. I probably won't upgrade to 1.4 for at least a year. And it was that way for 1.3 for me when it came out. I didn't switch to it for quite a while because I just want to make sure that the hardware adoption's there before I switch to it. So I haven't even really looked into it. I'm sure there's some good, useful stuff in there. But it's nothing I'm going to use anyways for at least the next year. So I figure when I get ready to look to swap to it, I'll look at it then. All right. Started a new adventure. Got a new book, The Scientist and Engineer's Guide to Digital Signal Processing. Oh, that sounds pretty cool. Granted, I'm neither a scientist nor an engineer, but I'm trying. Hey, I get it. Respect. Respect plus. Is Kohi using virtual memory allocation using OS primitives? It is kind of doing that on Windows, but not really otherwise. I need to actually fix that. One of these days. I just haven't gotten around to it. Basically, right now I'm essentially mallocing a huge block of memory and then divvying it up from that. My allocator sits on top of that block of memory, essentially. Funny you bring that up. Takes a drink. Yep, exactly. All right. So, so where does this leave us? Well, if we take a look at track, we have a bunch of stuff in here. I guess I could point out really quickly what the track wound up being, right? So we wound up going with 7 points, right? 7 points around the scene, right? I had to hard code these things. They're not configurable yet. Eventually I will get there. And so what this does is it generates all the triangular geometry that we need based off of this, and we automatically create Bezier handles at the start and end points of each segment, and they basically face in at 50% of the length, right? So they face from start point to end point on the left, for example, and they face each other. And same goes true for the center, same goes true for the right side. And that's what gives us kind of a nice starting average. We don't have the ability to control that yet. We'll get there eventually. So what I noticed, though, is after we create all the geometry, I'm going to keep all this stuff. This is fine. But in terms of constraining stuff to the track, I found myself writing a lot of stuff in here that kind of looked a little bit, like what you might see in sort of a physics system, right? And I'm like, I got thinking about it because we're not going to want to use the point system in terms of moving an object around for forever. We'd probably maybe switch to a sphere to have it be a little bit more robust. That would probably take care of the leaks. But ultimately, we're going to want like an oriented bounding box, right? Like a rectangle that can be rotated in space. That can, each of its individual corners can bounce off walls and stuff like that. And I got thinking about it a little bit more, and I'm like, being kind of constrained to just this track might make it easier to sort of program, right? Because I banged this out in a weekend, essentially. And I really didn't spend all that much time on it, right? So it was pretty easy to get going, but the problem is it has issues. It's not exactly what I would call stable, and it doesn't account for things like forks in the road or even being able to pass over one point versus another. I don't know how it would handle that. I don't know if it would even handle that, or T intersections or a circle 8 figure or something like that. I don't know how it would handle any of that stuff, right? And so I think this was a good exercise to see like how something like this might be done. But I don't think it's the solution I'm going to go with because it's a little too janky, I think. I think I want something a little bit more stable than this to build our systems on top of. And so what I'm thinking of is we're going to, and I wasn't going to do this initially, but I think we're going to build a very simplistic physics system. And when I say a physics system, it's not going to be like physics, where that's, has all of these complex interactions and stuff like that. I'm talking something that supports spheres, oriented bounding boxes, and those will probably be the only, I'm thinking those will probably be the only two sort of dynamic bodies. And then we'll have static bodies that can be of a bunch of other shapes, right? So we'll have spheres, we'll have oriented bounding boxes, maybe capsules for both if we decide we need that. I don't think we're going to, but maybe. And then for static objects, we'll also have mesh-driven bodies, right? And so that would be what this track is, right? So I don't necessarily want to make a dynamic body that deals with geometry like this, right? I don't think that's going to be performant. I don't think we're going to need that. I think we only need that for like static stuff. So the more I got thinking about this, the more I'm like, you know what? Maybe we should actually just, bite the bullet and try to stand something up that is going to be a little easier for us to build on top of. Because the other thing I was thinking was, well, if we always constrain to the corners of the track like this, at the edges of the track, then there's no sort of way for us to say, well, what happens if we come around this corner way too fast, right? And it's like going up a ramp and like we just sling off the side, right? That might be kind of a fun thing to have, where we could have like a crash animation or maybe the player getting ejected from their vehicle or something like that, right? And so sort of this system kind of limits us from doing that. Now I could say, hey, if the speed vector surpasses a certain point and we hit this, then we could say, yeah, it's a crash and fine. We could do it that way, but I feel like this is just a little bit too constrictive and it's going to limit us a little bit too much. And also, if we ever wanted to have some sort of free roaming capability, this would block us from doing that too. So while this system is good, I think we can do better. And so that is kind of my main motivation for wanting to proceed with this, right? So we've already kind of got the static geometry collision stuff figured out with triangle-based geometry, right? So I've got a couple of ideas on how I want to sort of standardize that and make that something that we can reuse. And then we also kind of have some point physics figured out. We don't have the radius stuff in there for a sphere yet. We don't have the oriented bounding box. We'll have to add those. But I think that we can definitely tackle that. So the plan is we are going to build a simple physics system, _simple. The only thing that this is going to support initially is some very basic properties. Maybe even, we might not even have friction, right? I haven't really decided if I want to do friction or just like a generic fall off value of some kind. I haven't even decided mass, if mass is going to be a thing yet, right? So essentially we want to have static bodies that don't move or react to collision, and we want to have dynamic bodies that do move and react to collision. And now that I'm talking through it, I think the dynamic bodies that do move and react to collision, I don't think we're going to support triangle-based meshes for that. I think it's going to be spheres and rectangles and just simple shapes like that, right? Dynamic stuff has to be super simple. And then, as far as static is easy as far as a sphere goes and an oriented bounding box, right? But the triangle-based mesh, that's something we're going to need. And the advantage here is if we had something like we wanted part of our track to be constructed with walls on the side or whatever, we could do that, but we're not necessarily bound to doing that for the whole entire track. And this would also make it easier for us to put like ramps in place, to be able to have things like in the middle of the track that maybe you could run into and crash or something like that. So convex hull would be a good one. Yeah, I mean, maybe if we get there, right? Because what I'm thinking is like if we needed a ramp, right? Realistically, we could just use a oriented bounding box and like angle it and like jam it into the ground, and you could still ramp off of that, right? Basic raycast would be great to include too. Very common to use. Yeah, so we actually, and funny enough, we actually have raycasting available. We kind of made it in our testbed application. And that's how we do object picking. So we're actually going to be able to take that and put it into the physics system as well and be able to standardize it. Let's see. ZumFN, first time chatter, welcome, by the way. Sorry, I got kind of caught up in explaining stuff there. NCL, I hope I pronounced that correctly. First time chatter, hello as well. Arseny Kapulkin, creator of Volk X Robot Graphics. Yeah, I'm familiar with him. Did a breakdown of Vulkan 1.4 changes on YouTube. He does it on each version launch. I'll have to watch that. Yeah, I'm very familiar with him. He's awesome. What is your project called? So there's two things. There's the Kohi game engine, which is what we're looking at for the roadmap right now. And then there's the actual game. So the engine is called Kohi. The game is called Overdrive 2069. And it's basically a racing / combat, vehicular combat type of game. Is there a GitHub? Yes, there is. And Spiro actually linked that. Thank you for doing that, Spiro. I appreciate that. Sometimes it takes me a minute to catch up to the comments, so you'll have to be a little patient with me there. How long till it's out? We actually literally just started developing the game. And this is the first game that we're developing with this engine, so there's gonna be lots of us going back to the engine and be like, oh, we need this. Let's put that in real quick. And the physics system is one of those things. And so we're going to keep this simple. I do not want to go beyond a couple of episodes on this. And I'm probably going to do a majority of it offline just so that we keep it simple. The engine is out, more or less, but it's not really proven, right? So we're working on version 0.9 right now, which I would consider pre-alpha at best. Does it work though? Like people can use it? I would not recommend using it at this point. No. And the reason I say that is because it's not complete. So one of the reasons I'm now building a game with it is to figure out what the workflow should be, and what the pain points are that I run into using this along the way, so that I can actually fix those things, so that when we do release the full engine out there for people to use, it's relatively easy to use. Would you need any funding for it? I mean, any funding always helps. I always appreciate any of that. So, this is just something that I'm doing in my spare time, but any funding helps with things like, offsetting the costs of hosting the website, which is here, by the way. I don't know why it gives me these weird size windows. So hosting the website, eventually I'm going to need to probably hire people to create some assets for me. Assets that I'm not capable of creating myself, like music or sound effects, things like that. So eventually, I'll need funding for those things. But yeah, any little bit helps. Sikelos Music, I have you in mind for sure. Definitely. So yeah, this is, like I said, this is just kind of the thing that I do on the side. What do I do for full time? So I was a game engine developer for about 5 years, but I had to move away from that because I got tired of working 70-hour weeks. And so now I write medical software as my day job because it pays the bills well, and I don't have to work 70 hours a week. Yeah, and 70 hours a week was not including my commute time, which at that point was an hour and a half in each direction, so 3 hours on the road a day, on top of working that many hours a week. So, yeah, that was rough. All right. Allow the user to fall off the track. Exactly. Yeah. So that's what I was thinking, Mahmood, is that we need to allow the user to fall off the track. We need ramps. We need to be able to jump over other sections of the track, or maybe jump over pitfalls or hazards or things like that that they might be able to fall down into. So we definitely want that. Can you show the main file of the game? I'm curious about how you're using the engine as a framework. So that is basically what this is. And it's only a couple hundred lines because we literally just started writing the game, right? And all of this stuff is available on the GitHub. Most of this stuff is under the release 0.9.0 branch. If you look at the main branch, that's the 0.8 release, and that has some of this stuff. Not all of it, obviously. But yeah, I would look at the 0.9 branch if you wanted to see the latest, greatest. Let's see. How long would you say till you get the engine out so people could invest in it? So I'm not going to officially release the engine until I've released at least one game with it. And the reason for that is because if the engine isn't actually being used to build something and release something, and if it doesn't have something out on the market, what is it really, right? So until we've actually gone through that entire process, and I mean launching the game and putting it on Steam, right? Until we've actually gone through that process and support everything that we want to support and get it released, final release, not like early access or any of that stuff. I mean, I'm talking final release. Until everything's nailed down, I do not consider this usable, right? I consider it a good resource and a good reference to be able to use, right? But the whole point of this is to show how we're building it from the ground up, right? And we're not done with it yet. So it'd be a bit like if you were building a car, you've got your engine and transmission on the chassis mounted there, right? And you've got a seat bolted directly to the chassis. Does it drive down the road? Sure. Does it have brakes? Sometimes. Does it have a cab? Absolutely not. Air conditioning? Nah. Windshield? That's a dream, right? That's kind of where we're at right now, right? Yeah. So it's not there yet, but we're getting there. Engine brake for the win. Yeah, downshifting for the win, for sure. Who needs brakes? Brakes are for noobs. AC is relative to speed. That's true. That's what I call rust holes in old cars, speed holes, / free air conditioning. All right. So, back to this. So these are the couple things that we want to support in our physics system. And I put that in quotes because, again, it's going to be super lightweight. And we're only going to program what we need. The second thing is something that I think that we should do. And we already kind of have done a little bit here in the track file. Is the ability to generate the triangles, the triangle data, based off of the vertex and index data. We actually have all of that logic in here. So what we need to do is take that and apply it to our geometry. So our K geometry right now is basically just a struct that says, okay, we have, here's a vertex count, here's the size of each vertex, here's an array of those vertices, and here is an offset into the vertex buffer when it's uploaded. And then we have that same set of information for indices. And so what I'm going to do here is say we're also going to add a function to it to say, take this geometry based off the vertex and index data and generate triangle mesh data that we can then feed to the physics system to generate a mesh, right? And that's going to be primarily for this guy, right? And so we'll essentially be able to feed the triangle data of our track, which we already actually have. We'll be able to feed it to that directly. And the way that we're going to work this is it's going to be optional and not done by default. So Not every mesh that we upload is going to need to have this done, because maybe we don't actually use that particular geometry for physics, right? So this is going to be something that we have to sort of opt into and do as an extra step. And then we're going to add a function to re/generate this basically and store it in the K geometry. So the K geometry will essentially have a size and a pointer, or an array of triangle data, right? And that will either exist or not exist depending on whether this has been called. And so it won't take extra memory on stuff that's not going to use it, but it will allow us to actually use it when we do need to use it. So I think it's a little bit of the best of both worlds there. And then we can take that to create these other things. So I think this is going to be the first step that we're going to tackle tonight. And then we're going to start setting up our system, complete with all of the initialization, all the world config, things like setting up, what gravity should be, and then what all the structures for all of these bodies should look like. We're going to set all that stuff up tonight. So I hope that makes sense, and we are in for a lot of work tonight. Rust is lighter than carbon fiber. Yes, that's true. I mean, the thing about it is, if you see rust on the frame, you just pretend you didn't, and then it's not there, right? If you go fast enough, you might use air braking. That's true, especially when you land. That's not really air braking, it's ground braking, but, it's more than one way to break ground, If you have any rough ETA when the game will be out, I'd be happy to see what I can do to fund the website and everything. Okay, I don't have an idea for it yet, but here's what I'm thinking high level. I know that the game is going to take at least a year to make. And the reason I say that is because we are going to have to go back to the engine and do stuff, right? We're going to have to fix things and fix bugs in the systems that haven't been thoroughly exercised and things like that. And then also, I'm thinking it's probably going to take us a year to get to feature complete. And then from there, it's probably going to take another few months at minimum to get to what I would call a beta that's more stable. And then at that point, I'm going to open up testing and have people just run it through the freaking grinder and knock out as many bugs as we can, because we want a stable product going out the door. So, we'll see where we are on that. It totally depends. I have no idea yet in terms of projections on any of that stuff yet, though. How much would you need then? I have no idea, to be completely honest. So I'm planning on doing as much of the artwork myself as I can. I do want to do things like I do want to hire music composers and things. I know Sukelos Music, I have him in mind. I am going to obviously have to advertise. I am going to have to do stuff like that. So obviously that's going to be a thing as well. Also, we want to localize, right? So Tammin brings up that point. We are going to localize this game. It's not just going to be in English. And so obviously our translators, I don't want them to do that for free. I do want to pay them for their efforts on that as well. I don't want people doing stuff on this for free. So if anybody does contribute to this, I want to compensate them. So I just have to balance that with like, what can I afford to do with the funds that I've collected so far, and rate limit that so I don't make myself broke, right? So it's not planned out well enough yet for me to know what I would need. I think once we get a little bit further down the road, I'll know. At least in the tens of thousands, probably by the time we're done. Yeah. Hopefully not, though. Like, I'm going to do whatever I can do to get around that, but I don't think it's going to be that much. I'm going to try and keep it from being that much. Like, I can't afford that. So, yeah. Anyway, Be shocked if it was less than 20. It depends. Again, I know there's been lots of developers out there who have released products on less. The biggest problem is going to be spreading the word so it sells well. But we're not there yet. I'm not even at a point where I can make promotional material yet, but try to stay updated. I appreciate that. Yeah, definitely. We're going to take this slow and we're going to do it correctly, right? I don't want to rush it. Do you have any idea how much the game will go for? I don't yet. Well, okay, I have some ideas, but I don't necessarily want to mention it yet. Only because I'm still doing research on it, and I have a couple of price points in mind, but it also depends on how big the game gets. Because I was just talking to Spiro, yesterday, about something that I might add to the game that I haven't talked about yet. So, if that feature winds up getting added, it might drive the price up a little bit, but we'll see. Okay, so the first thing we need to do is go into our K geometry and think about how we actually want to tackle putting this in there. And we already kind of, if we take a look at K geometry, we have all the stuff I mentioned here, right? So we have generation every time we update it, that increments the center, the extents, the vertex data, and the index data. What I'm going to do is we're going to say U32 triangle count, if I can type. And then we're also going to do triangle tries, right? And this is going to be, let's see, did I actually define this? I can't remember. I think I did. Yes. So a triangle, all a triangle is it is just 3 vector 3s, right? It's very simple. That is all that makes up a triangle. That is all that's going to hold. Now, we could argue that these triangles, right, these vector 3s could be pointers to vertex data, right? The reason I'm not going to do that is because, oh, you know what? I just thought of something too, though. This needs to be a triangle 3D. 3D. Because we might have 2D triangles at some point. So we should probably just define that, right? What that looks like. And I suspect that we're going to have this when we do some more advanced UI stuff. So let's go ahead and define it. Even though we're not going to need it right now, I think at some point we are going to need it, right? And that's just the vector 2 of those things, right? So instead of triangle, we're going to have triangle 2D and triangle 3D. And so this is going to be triangle 3D, 3D. That brings an interesting conundrum, though, because geometry isn't necessarily, well, I guess it's kind of 3D because of this. We might wind up changing this to have like an array for each type, right? Or maybe we have an array of triangle 3Ds, an array and an array of triangle 2Ds, but only one can be supplied at a time. And then we just use this count for both. Maybe we do that. But I think at this point that's what I'm going to stick with, because when we need 2D triangles, we'll come back. Sounds good. Just shoot me a DM on Discord and Twitter if you ever want to talk funding. Pretty sure I can give you a good hand. I appreciate that a lot. Thank you very much. That means a lot that you would offer that. Thank you. I don't want to do it without a plan, you know? I don't like jumping into things like that with funding and all that stuff without a full plan, right? So, but I'm definitely going to keep that in mind. So thank you very much. And if you want to shoot me a Discord DM, I can add you on there so I can keep you up to date on that. All right. So we have this, and I think the way we're probably going to do this is, let's see, geometry H. This is where all of our geometry stuff is anyway. So we'll just add a exported function. We're going to put, I guess we could have this be return type Boolean just in case. Geometry, generate. No, I don't want to use generate. Calculate triangles, I guess. Right, and we're just going to take a kgeometry pointer to geometry. And that's actually all we're going to need. So, geometry C. Let's go down here, paste this. Perfect, added you, sent you a little wave GIF. Just keep me posted. Awesome. Let me see. Gotcha. Okay. Cool. Thank you for that. Appreciate it. All right. Tough to be a project manager, lead game developer, designer, huh? Yeah, exactly. Yep. I'll manage, though. I will manage. It's not my first rodeo, thankfully. Okay, so obviously if we don't have geometry, then we're going to return false. Wow, I cannot type tonight. Okay. Otherwise, return true if everything was successful. Now, we're going to go into track, because this is actually where we generate this stuff. And I think that was under initialize, I want to say. Tessellation. Here we go. So we do triangle and adjacency data per segment. So this is another point that we should probably discuss, right? So we can generate the triangles here, but this adjacency generation is something we might want to talk about too. And I think this is something that we could probably also generate at the same time. So what adjacency data is it basically, although this is a bit specialized to the track, right? So maybe not. So adjacency data is essentially saying what is the index of the triangles on each of the triangle sides that neighbors it, right? And so here we have just sort of a hard-coded function where we have an index of an array into an index into an array of triangles that are adjacent to it, right? And if there's nothing adjacent to it, then we use invalid ID to specify that. So for right now, I'm not going to worry about this, right? We can do this in a separate pass if we wind up needing it. I'm not sure that we will. So we'll see. We'll see where we wind up on that, right? And I might even do that as like a separate pass here. But what I'm going to do is all this is essentially coming through here and just saving off a copy of the vertices, right? So let's see. Let's take this loop. I think this is actually all we're going to need right here is this bit, and we could just refactor this to what we need. So we'll say U32 vertex index and U32 index, right? And we don't need this segment resolution thing. We just need to know how many triangles we need. So we need to figure that out first, right? So we can do geometry triangle counts is equal to, and we'll do, let's see, it's going to be geometry index count divided by 3. Make sure that's right. Yeah. As long as it's not a triangle strip, that will be fine. So we'll put a note in here. This assumes a triangle list. A strip would not work here. We don't really use triangle strips, so that's fine. So we take the index count divided by 3. That's going to give us how many triangles we have. Then we want to do geometry triangle count, right? And so we're going to loop through our triangles, right? And we're going to, that's triangles are going to be indexed by t, and then we're going to have, we are going to have the vertex index incremented by 3 every single time. And then we are going to, at the bottom of that, this is another important bit, at the bottom of this loop, which is going to be here, just before we kick out, is going to move the index plus 12. That's actually not going to be correct. That's going to be, I think that's going to be plus 3 as well. Is vertex index going to be, I don't know that that's correct actually. Let me think about this for a second. So triangles, segment triangles. Okay, so this is going to be triangle 3D. Try is going to be geometry tries, try index. Okay, so this try index is actually just going to be t. Okay, so for each one of these, we essentially need to get the, actually I don't think this is the right loop that we should be using. We should probably be using, we should probably be going off of this data instead. We need to move, we should be using the index. Yes, we should be doing 3 indices at a time. Vertex index, we're actually not going to need that. Right, okay. So this is going to be, let's just take this. So triangle verts is going to be verts, which we have to get actually. Geometry, actually, vertex 3D array verts equals geometry vertices. Okay, so we want verts, and then the index needs to be verts at the index of this, right? So we need to say, we need indices here too. U32 indices equals geometry indices, right? And here we need to say indices sub II plus 0, 1, or 2, right? And then we also need a closing bracket there. Okay. So what we're essentially doing is we're saying, okay, grab the vertex index from this position in the index array, right? So we're just moving this forward each time by 3. So the first one is obviously offset of 0. The second one's an offset of 1. The third one's an offset of 2. We grab the vertex index for that. Then we use that index to index into the verts array. That will give us the proper vertex where we can then extract the position from and save that off to the correct try. So we don't need that. That is it in terms of generating that data. It's actually pretty straightforward. Now, the adjacency data is not going to be as straightforward, and that's going to be because we don't necessarily know how the mesh is going to be laid out, right? So we may need a better way to look that up. Got to get going. See you later. All right. Awesome. Thanks for stopping by. I appreciate it. All right. Okay. So we have our triangle data is there. Although we didn't allocate the array for it, so we should probably do that. C array. This is going to be triangle 3D. And the count is going to be geometry triangle count. Now, we should probably do a little bit of verification / validation here, right? What we always want to make sure of is that we have a correct index count, right? So the index count should always be divisible by 3. And if it's not, then that means that we have vertices out there that aren't necessarily, wait a minute, indices rather. Indices should be divisible by 3, not vertices. Because we should only be dealing with triangles, right? So we should do U32. Actually, I don't even need to save that off, I guess. We could just do if geometry index count mod 3, right? If that's anything other than 0, invalid index count that is not divisible by 3, thus I should say thus a incomplete degenerate triangle exists. Okay? And we'll want to return false there. Okay. The adjacency data is something we're going to have to figure out, though, I think. Because we are going to need to know how to do that at some point. But for our brute force solution, we don't have to worry about that for now. That's going to be an optimization we can put in afterwards, right? So that's good enough for right now. Did I put this in the header file? I don't know if I did. I think I did. Yes. Okay. I suppose we ought to do documentation comment because we're probably not going to come back to this function anytime soon. So generates triangle data for the given geometry. Pointer to the geometry for which to generate the data. And then, return true on success, otherwise false. Okay. So that is pretty much all we need to do there. To do. So this bullet point is done. Now, we can start thinking about the, whoops. What did I hit there? Must have hit page down. We can start thinking about the design of our physics system. So the first thing we need to do, obviously, is create our files for that. So we're going to put this in runtime because I don't think it makes sense for it to exist anywhere else. So we're going to put this under source, and then obviously, well, okay, we could put it in systems. Do I want to put it in systems, or do I want to have it kind of its own thing? Like renderer is kind of its own thing. Audio is kind of its own thing. The physics system, I feel like, might grow big enough where it might warrant kind of its own section. Let's see. Innocence, first time chat, welcome. Dingus Dev, thank you for the lurk. Have you thought about launching a pump fund to support pump fund? I assume that's what you mean. To support your game engine. I don't know if you've seen Coding Butter. He's done something like that on live. I've not considered that. Is Pump Fund what you mean for that? Is that what you mean? I've not considered that, though. That's an interesting idea if that's what you mean. Oh, it's like a actual... I see. It's like a Kickstarter type of thing. Interesting. Okay. I will take a look into that. Thank you for this suggestion. I'll take a look into that. I don't know anything about it, so I will look into it. Appreciate that. I've got it open on another tab. Okay. So yeah, I think I'm going to create this. This system's going to be a little bit different. It's going to be, I think eventually it's going to grow to be kind of big. So let's add a new one here. We're going to go physics. Right? And then in here, we're going to do physics types, H. We're going to do a K physics system, H, and a C file. All right. So we're going to start with the types first. I think that makes the most sense. Okay, so let me open up actually the to-do over here so that we kind of have a reference of the things that we kind of want to do. So we need to think about our types first. So everything in the physics world, well, first of all, we have the physics world, right? So even that is probably something that we could set up. So maybe we'll do K physics world. That's going to be a struct, obviously, right? K physics world, right? And we'll fill that out in a second. We are also going to have everything that's in the world is going to be represented by some sort of what we're going to call a body, right? Which is kind of a standard term. First thing, we should probably put something in here. Let's do F32, or actually, I guess it would be, let's do Vec3 gravity. And we'll come back to that, right? Okay. So we're going to have bodies, right? And these bodies are going to be ultimately what represents our physics in the scene. So we're going to have either a static body that doesn't move or react to collision, or a dynamic body that does. And so we need a way to represent that. So what we're going to have is a type def. We're going to have a struct, and we're going to call this physics, or I guess K physics body, right? K physics body. And this body will have, at least for now, two types that I can think of. So we're going to have an enumeration for this, K physics body type, right? K physics body type. So the two types are going to be K physics body type static, which is going to be sort of our default, or dynamic. And we already kind of have this in our track solution inadvertently. We just don't have it actually labeled or defined as anything, right? But we're already kind of doing this. So those are the two types. So that's obviously going to be a member here. So K physics body type. We'll just say body type. All right. And then the next thing we're going to have is we're going to have we have these different sort of subcategories, if you will, in here. Sphere, rectangle, we'll probably have capsule, some other stuff later, or triangle-based mesh. And we're going to call that a shape type. So we're going to type def an enumeration for that. We're going to say K physics shape type. Shape type, right? Physics, whoops, shape type. Now, there's going to be a few different types. So obviously we have sphere. Oops, that should be an underscore. Right, so we're going to have that. We are going to have rectangle. And then we're going to have mesh, right? But I'm thinking maybe should we have like an unknown type that's kind of like an error scenario if it's like zeroed out memory? Maybe, or maybe not. Like maybe sphere should just, maybe everything is just a sphere by default unless we say it's otherwise, right? Maybe sphere is the default case and maybe static is the default case. I don't know if I want to put undefines in here yet, right? I'm thinking no, initially for now. So that way zeroed memory is kind of a default that just kind of works, right? Although you'll have a default radius of 0 for a sphere, but we'll get to that when we get there. Okay. So, the sphere basically defines two things. It defines a position and it defines a radius. The rectangle defines a little bit more than that. So it also has a position, right? It's sort of center. And then it has half extents in each direction. So half width, half height, and half depth. And the idea there is that it's basically centered around that point. Now, I don't know if we're ever going to change that. I suppose if we ever did change it and we need like a non-center center of mass. I know that sounds weird, but say the object is heavier on one side than it is on another, then maybe we would have to switch that up. But for right now, like I said, I'm keeping it simple. We can always append onto that later if we need. So we have the body type is the first thing. K physics. Shape type is the next thing. And then we actually want to have some sort of reference here that we can look it up by, right? So we want to have a name. So we're going to use a K name for that. And incidentally, the world itself can have a K name. That's really just for like debugging purposes, I guess, because everything will be against the world, right? And so I guess that makes the most sense. Okay, so there's a couple ways that we can do this. We can define all the properties that we need on the physics body. And then only use the ones that we need for the particular thing. Or we can have something that uses physics body as a base and sort of adds properties onto that, which that's kind of the direction I'm thinking that we want to go. Although the first would probably be much easier to manage, actually. So maybe we'll just do that. But a couple of other things that the physics body is going to need. So they're always going to have a position, right? So for a sphere, the position will be used as the center, right? They're always going to have a velocity. Now, if the body type is static, the velocity is meaningless, right? So we just don't do that. But we can still have it there anyways, right? It's not like it takes tons of memory to represent that. And then I guess what we could have is, So sphere would have F32 radius, right? And we might even be able to union these later on. Whereas the rectangle would have half extents, right? So so the rectangle would have, let's see, how do we want to do this? I think we can actually just vec3 this. Half extents. Right? So half extents on all the axes. Right? X, Y, and Z. So we have that. I guess we also need a quaternion rotation, right? All of them are going to have that. They're all going to need that. I'm I kind of don't want to support scale right off the bat, because that complicates things. I feel like the mesh itself could be scaled, but I feel like the physics object probably shouldn't be. Let's see. Abel, how's it going? Late to the party, finally physics, yep. Where's the bean or the bean shape? Do you mean capsule? Because that's like another one I was considering in here. Capsule is another one we might use. I just haven't really decided that if I'm going to need it. So I'm trying to only add what we're actually going to use. So I'll put it in there, but I'm going to leave it commented out. I assume that's what you mean by bean shape. Okay, so we have position, velocity, rotation. I'm not even going to put friction in there just yet. I think we can wait on that. Okay, so the rectangle will need half extents. Now, the mesh, whoops. I can't type tonight. The mesh is going to need a list of triangle 3Ds, right? So actually we're going to need U32. Triangle count, right? And triangle 3D tries, right? The rectangle's not going to need that. Neither is the sphere, right? So those are only going to be used for the mesh, which again I think is fine. I think that might be everything we need. Let me move name further up here. Okay. Are you a full-time streamer? No, definitely not. I wish I was. But yeah, I cannot afford to make that happen. Don't have the following to make that happen. Not even close, unfortunately. Yeah, it doesn't pay the bills, right? Maybe someday. It's the ultimate goal. Isn't it better to store a TRS matrix instead of individual vectors? I don't know yet. It might be. TRS matrix meaning translation, rotation, scale. You're talking instead of these things. Well, okay. So, realistically, a TRS would replace these two. And then, whoops, crap. And I don't have scale yet, right? So, I mean, yes, I could use a matrix for that and then just extract the properties from it. But I don't know if I'm going to need that. We're going to see. I'm probably going to need that if I ever go down the scale route, right? But for right now, I'm not going to support scaling. Like I said, I'm trying to keep it as simple as possible. But you're not wrong. Let's see. What is your main profession? So I was a game dev, a game engine dev for about 5 years. But now I write medical software during the day because I got tired of working 70+ hour weeks. So, yeah, that's what I do now. Pays the bills, right? Okay, so we've got physics body. Let's see, what else are we going to need? Eventually, we're going to need like physics materials to define like surface friction and things like that. But I don't think we're going to go down that route just yet. So I think this ought to be enough to get us started, at least. That'll cover all these different things, right? So let's start thinking about what the interface is going to look like. So first off, we're going to need a physics system initialize. Oh, and I forgot a couple things. So we're going to have physics system state. Right? And I don't actually know what this is going to have in it yet. I guess it could have like the active world in it, I suppose. So maybe we have physics world, right? Active world. And some other stuff. I don't know. We'll figure it out. Okay, so we have a state. We need a state. We also need config. Right? And right off the bat, well, I don't know what the config could contain either, so I'm just going to do U32 dummy. I'm sure we're gonna come up with stuff that's specific to the config, but for now that'll work. Okay, so like our other systems, we're gonna have a U64 pointer, and that's gonna be memory requirement, right? And that's gonna be how much memory does this system require when we initialize it. That's more or less just gonna be the size of this state, right? I suppose we could keep the config in here too, so we could say let's do this, right? So we could say physics system config config. We'll just keep a copy of it there, right? So we need physics system state, and then we also need physics system config. And the way we're going to treat this is basically memory requirements always going to be required, right? So that'll tell us how much memory we need to allocate for the system. And essentially when we're trying to get what that memory requirement should be, we're going to set this pointer or the value pointed to by that if this past state is 0. So the way we're going to do this is the double call method, where we call this once to get the memory requirement, allocate that memory, then call it again, passing this again, and passing state along. And then that's when we'll actually do the initialization. And then config, we're going to make optional with some reasonable defaults within initialize. And then, yeah, we'll go from there, right? And then if you want to override that, you can do that. Actually, I just thought of something. This should be, U32 steps per frame, right? Maybe we'll do that. Okay, so we need the initialize, which I just realized I spelled wrong. There we go. We also are going to require a physics system shutdown. K physics system state. Right, so obviously we have a startup and a shutdown. And then K physics. And we're actually just going to say for everything else other than initialize and shutdown, we're just going to say K physics underscore. We're not going to put the system in there because that makes it super verbose. So we're going to say K physics update. And we're going to do K physics system state as usual. And then we'll do a F32 delta. Actually, I guess we'll do frame time. Is what we've been calling it, right? And that will do all of the iterations that are needed for that particular frame. The next thing that we're going to do is, let's see. I think that's actually all we need for the system itself. So you know what? The update itself is going to be system. But everything after that is just going to be K physics underscore. So the first thing that we're going to need to do is we're going to need to be able to create a world, right? So we're going to do K physics world create. And this will be K physics system state, obviously. And then let's see, how do we want to handle this, right? Do we want to handle, or do we want to just, I think we should just deal with pointers for this. So we want this to be fast. We don't want to have to be doing handle lookups all the time for this. So I think we're going to do K physics world, right? And that's going to be out world, right? And then I guess what we should do is K physics world. I guess we should say set world, right? And this is going to be largely the same arguments. So this is just going to be world. So what this is going to do is that's going to set what the active world is in the physics system. So we have creates. We should probably also have destroy, right? So we have that. And then we'll need the ability to add bodies to it, right? And so I think we're probably going to follow something relatively similar to how we create the world. I was just thinking, actually, we should also define vector 3 gravity, right? Now, why did I set vector 3 as a gravity, right? Isn't gravity always, negative y is down? Most of the time, yes. But what if we have something where we want the gravity to suddenly move, to the side or something? We don't necessarily want to eliminate us doing that, right? Let's see. By the way, SDL3 just came out recently. Have you tried it? What's your opinion on it? I have not tried it. I haven't had the time, frankly. I've heard it's really good, though, in terms of API. They've done a lot of work around the API to make it much, much better. So I have heard that it's much better. Okay. Maybe one of these days I'll throw together a test project with it, but I just haven't, frankly, had the time between this project and work and everything else. All right, so KAPI, we want Boolean again, K-physics, body, create, right? And we're going to do, I don't even know if we need the state for this. I don't think that we do. I feel like we need to have different function signatures for each of the shape types. So let's do sphere, right? And we'll say I guess the main properties we're going to need for that is vec3 position, vec3, f32 rather, radius, and then we'll do a k physics body, out body, right? So physics body create sphere. Let's see, I feel like there's something else. Oh, we need to specify the body type, right? Whether it's static or dynamic. Because that's not really going to change anything in terms of creation except what flag gets set. So we have create sphere. And then we're going to have create rectangle, right? And so this one's going to have position and then vec3 half extents. But otherwise it's going to be largely the same. And let's see. We should have the ability to set rotation on those. And then I guess we'll do one more for mesh, right? So we'll go do create mesh, right? And so this is going to have position, and then it's going to have U32 triangle count, and then triangle 3D tries, right? So we have the ability to create those three types. And then the destroy is pretty much going to be the same function call for any of them. So kphysics body destroy, or destroy. Yeah, that's fine. Wow, I typed it wrong twice. There we go. All right, so this is going to be, I think we just need to do kphysics body, right? So we'll destroy that. Also, we need rotation set, right? So that's going to be a quaternion rotation. We're also going to want position, set, right? So it's just going to be a vec3. Oops, wrong button. Position, right? So position and rotation. Eventually, we'll want the ability to like apply impulse. So I guess we could do that too. Kphysics body apply impulse. Kphysics body vec3 point, and I think it's just a F32 force is what we're going to want. That might wind up having to actually change, but basically it's saying at this point how much force to apply an impulse. Let's see, is there anything else that I can think of that we would need for that? I don't think so. Okay. So, we can do B8 kphysics world. Add body, right? So kphysics world, world, and then kphysics body. All right. I think that is pretty much everything we're going to need to get started. I'm sure there's going to be other functions, but this is basically what we need. Let's see. J Henny 305, first time chatter, welcome. How are you doing? You were asking what's the game about. So the game that we're making is a 3D racing game / vehicular combat, right? So we're gonna have both melee and ranged combat, and there's obviously going to be hazards and things to dodge in the racetracks and things like that. And I have some ideas on some other gameplay modes that we're going to add as well, but I need to flesh them out before we talk about them. But yeah, it's basically 3D vehicular combat racing. Death race, if you want to think about it that way, is kind of what it's turned into. Latest video from Sebastian Legg basically starts with Y to use gravity as a vector 3. Yeah, exactly. Yep. Have you ever had spam musubi? Yes. I've actually had it in Japan too. It's amazing. Love it. Force should be a vector. No, what's the force direction? Yeah, that's what I was thinking. I was like, this didn't feel right because it should be a point, like a point and a direction. That's why I was like, So yeah. You're having some right now? Awesome. Now I want some. Dang it. Made me hungry. This game reminds me of a game called Drive to Survive I played when I was a kid. I don't know if I played that one. Let me see. Well, okay. It's apparently a series on television, a Netflix series. It's on Steam. Cool. I'll have to check it out. Might find some interesting ideas there. Carmageddon, that game was awesome. Yeah. I'm a huge Twisted Metal fan. I played the crap out of Twisted Metal when I was a kid. And I realized when I was talking to Spiro, I don't even want to say this because it pains me to say it. Twisted Metal is 30 years old. Yeah, so come on, browser, do the thing. Apparently, it's not going to allow me to drag tabs now. Why? Okay, there we go. Yeah, this is what the game looked like there. Yeah, this game was 30 years old. But I played the crap out of this when I was a kid. And I was actually thinking it might be cool to add some stuff from this in there. Yeah, it's painful to hear. Yeah, exactly. Like, I didn't even really want to say it, but I said this to Spiro the other day, and he actually made me delete it out of chat. It's actually called MASH Drive to Survive. Yeah, I did find that one too. Oh, that's a different game. Let's see. You're probably talking about this one. PS2 game. Okay. That's definitely 2004. Okay. I don't remember that one for some reason. I don't know why. Anyway. It's like a truck 30 years old. Yeah, I know, right? Like, I remember playing that soon after it came out, and yeah, it hurts. It hurts a lot, for sure. How was multi-streaming for you? I noticed you were doing it and was wondering your opinion on it. It's okay. I haven't had any issues with it. I've been considering expanding. But if I do that, I'm going to have to find some way to unify the chats. And I know there's a couple ways out there. I just haven't done it yet. But yeah, I usually stream to YouTube and Twitch. But I've been considering expanding to other platforms as well. Makes me think of Twisted Metal on the PS2. So everything... Maybe this is a bit of a hot take with some folks that never played the originals. But everything after Twisted Metal 2 is rubbish, in my opinion. Absolute just... rubbish. There's just no way to put it. Twisted Metal 1 was awesome. Twisted Metal 2 was the GOAT. Anything afterwards, garbage. Won't play it. It was just terrible after that. Yeah, 100%. Yeah. In fact, I found a browser version of Twisted Metal 2 the other day, and I still remember even the sequences to like make the car jump and get the shields and stuff. 30 years later, I still remember it. Elden Ring garbage, yeah. I meant every Twisted Metal game after that was garbage, not every game. Although I could argue a lot of games now aren't quite as good as some of the old stuff, but maybe that's boomer logic. I don't know. Oh, you know what? I'm a dingus. I put all of these in physics types. These should be in the physics system age. Let's put those here. And then include pragma once, actually first. And then include the physics types. There we go. And then I'll grab all these once again. Physics system C. Pasta all those in place. Include physics system. Okay, physics system. There we go. Okay. All right. So, oops. Basically just going to start laying these out one at a time. And what we're going to do is we're going to keep all of the collision logic and all of the resolution logic and all that stuff essentially internal to this compilation unit. We're not going to expose that to the API. We want to keep the API for this as simple as possible. So first off, if we don't have memory requirement, return false because we need that. If we do have it, then we're going to set that to size of k physics system state. Why has it? Okay, I don't need that. All right. And then if we have not yet provided state, because we need to allocate it, we'll still return true, because we've done everything we need to up to that point. Now, config, steps per frame, did we have that added to the system state? In fact, the system state probably should be not here. That should probably be here. We don't really need that externalized either. Okay, so active world, we have config. So I guess we don't really need to do that. So we'll say if config, then we'll apply the properties, right? So we'll just say state config equals config. Otherwise, no. All right. And at this point, we'll turn true. Now, that's obviously not all the initialization we're going to need. That's just to get things set up and rolling for now. What is this complaining about? Oh, right, because I took the type def out of there. So it's going to be struct k physics system state, which means I'm going to have to add a struct tag in front of all these. That's fine. Okay. All right. Shutdown. Oh, you know what? Shutdown's typically a void. There's not really a whole hell of a lot we can do about it if it fails to shut down, right? Because we're shutting down the game engine anyway. So we'll say if state and then do stuff. We'll come back and handle that later. All right. So updates, we're not going to be able to do just yet. But what we can do is if we don't have state, return false. False. Otherwise, return true. Okay. We should probably, before we forget to do anything else, first off, we should probably do right down here kinfo physics system initialized. Just to kind of give us a little logging there. We should register this with the engine. So we need okay, struct physics system state physics system. All right, and we'll do U64 k physics system memory requirements. Right, so that way the engine owns the memory for the system, as with all of our other systems. And then when we set this up, let's see, we can set this up probably quite a bit later than some of our other systems, right? Definitely after the VFS, definitely after the asset system, definitely after the resource system. Our plugin system probably also ought to be stood up. KVAR system input. I suppose it, yeah, this is probably good a spot as any. Let's see, do we want to, yeah, we can set this up before the renderer. Maybe we'll set it up after the KVAR system, just in case there's any KVARs we want to use. We can do it before input though. Yeah, right here seems like a good spot. All right, so K physics system config. We'll just do config equals 0, right? And then config steps per frame, we'll just do 10, right? And then with a to-do, via app config, right? We want to eventually configure that through app config, but for right now, we're going to hard code it. Okay, so we'll do k physics system initialize. Memory requirement is going to be the address of systems physics system, and then states is going to be 0, and then config is also at this point going to be 0, and then we'll do let's see, systems. Oops, this should be physics system physics. Wait a minute. Didn't we have K-physics? Oh. Let's just do that. We want the memory requirement there. Okay. So systems physics system equals K allocates. And then we want the systems memory requirement. And then memory tag engine. And then we'll call this again. But this time we'll check the result, right? We'll say if this failed to launch, then we'll go ahead and bleat about it, right? So we'll just copy pasta this. That's fine. Fail to initialize physics system. Okay, so this time though we need systems physics system, and we'll take it in the address of config. All right. So now that's registered with the physics system, or with the engine rather. Eventually we'll need to do some sort of deserialized config if we want to parse config from it, but we've got a to-do here. This is enough for us to get started with now. We do need to do that before we release the engine, obviously, but we don't have to do it right this second. Okay. So now that the engine knows about that, we probably ought to at least get all these returning something and then build it and make sure that the initialization actually works correctly. Let's see. Imagine a guy just playing the same game for 30 years and refuses to play any new games. That would be hilarious. I'm sure there's somebody out there like it. It's more or less GTA 5 Online and Skyrim. Yeah, you're not wrong. Or World of Warcraft is getting up there with it too. It's 20 years old. This engine was an excuse to rewrite the game and mod it. You're not wrong. Skyrim is turning 14 this year. Yeah. Well, I remember when Oblivion came out. Okay. I remember when before that Morrowind was the newest game. So Path of Exile might be that game for me, playing for 7 years so far. Yeah. I played World of Warcraft for like maybe 12 years. 10, 12 years, something like that. I did eventually quit, but do you separate your application from your engine? Yes. Just started a whole asset system refactor. Good luck. It took me like 6 months. Did I mention to switch to use EA STL? I'm loving it. Is that EA's STL library that they open sourced? Is that what you mean? That's great if you're using C++, but what's the status line below your Vim status line? So you're talking about this down here. This is tmux at the bottom there. So I've got terminal multiplexer running. Yeah, it is. It's insane. Nice. Yeah, I've never actually used it because I usually just wind up writing my own. Mainly because I don't need all the stuff they put in that. I've been playing Spiral Knights for 8 years. Jeez. Hey, what have I missed? Well, I can actually show you because I haven't tried to build yet, so I think I can actually still run it. I'll show you real quick, me and Mr. Mustard, what got done offline. So we kind of came up with this this sort of very rudimentary track design. We got the track working with Bezier curves, generating the geometry and have the ability to traverse along it with a point that I'm then using as the position for this particular rectangle, right? And so I have the ability to sort of go all the way around the track, and you can see actually the console stuff of me switching triangle faces here as we're kind of traversing along, right? And it respects the height and all that stuff, and you can't drive off the edge and that kind of thing. And so I got this working over the weekend. And it's okay. It's a decent start. but what I essentially decided was this isn't robust enough for what we're going to need. And I was already well on the way to kind of writing lightweight physics simulation anyways. So I was like, I should probably just take that stuff and move it over to a simple physics engine. And we're going to set up a very, very, very simple physics engine that we're going to drop in and replace this with. And that physics engine, instead of just manipulating a point around, is going to be able to have spheres, oriented bounding boxes, so we'll actually be colliding with this box instead of just moving a point around. And then you'll be able to have mesh or triangle mesh based bodies as well. And so we're basically taking what's been written in here and we're going to reuse that as part of our physics engine. And we're basically just going to standardize it a little bit and make it a little bit more stable, because you can see as I move around here, it kind of, jitters a little bit, right? And it's not the greatest, right? And so, yeah, that is kind of where we are right now. We're just kind of kicking off the writing of a physics library. And it's, like I said, it's going to be super simple. We're only going to write what we need to actually make the game run, and we'll add to it as needed. My goal for this is just to have this be 2 or 3 episodes max, and have a physics simulator that works for what we need it to, and then we'll move on from there. So we'll see where we wind up with that, but that's kind of the goal. So we're setting up the system now. We've just started scaffolding the code. We've got all of our types for physics bodies in place, and now we're just kind of scaffolding out all the functions and getting ready to set all that stuff up. So, yep, good progress indeed. Yeah, for sure. Welcome new chatters, by the way. Is that water hand-coded in your engine? Yeah, everything here is written from scratch. Yep. The only things that I didn't write from scratch are, there's a couple of header-only libraries that I use to load a font file, to load various image formats like PNGs, Targos, things like that. But those are purely import processes and aren't part of the runtime. Everything else is written from scratch. Looks really good, and that's awesome. I appreciate that. Thank you. And thank you guys for the follows, by the way. So what we're doing now is we're just kind of starting to set up our physics system. Which actually, I don't need this to-do over here anymore. We can actually open up our physics types. So now we're going to start actually setting up what our physics bodies look like. Or I guess we should probably start with the world, right? Our physics world is going to have physics bodies in it. However, I'm debating in my mind whether we should have 2 different arrays, one for static bodies and one for dynamic bodies. If we should split them up that way, or if we should just keep them in a contiguous array for now, because we're going to have to add like a BVH or something. Maybe I'll just stick with an array for now, and we'll just kind of do a boomer loop over it for now. We'll brute force it, get it to work, and then we'll optimize afterwards. Separation makes sense? Yeah, but the separation will make less sense when I go to put spatial partitioning in. So it makes sense now, but I don't know if it's going to make sense of the dynamic and static. Yeah. I feel like it's going to make it makes more sense now, but yeah, I think once we put spatial partitioning in, it's going to get in the way. Thank you for the follow, by the way. All right, so physics system update, we'll come back to that because we've got all sorts of resolution and stuff we need to write. So obviously we're going to need, oh, you know what? These are in the wrong order. The out parameter should always be last. So we want our vec3 gravity to be the second parameter. And we'll just do that here as well. Oops, right there. Okay. So if we don't have states, or actually, you know what? For this, we don't even need state, actually, for this one. We might need it for that. Because we need to destroy everything that is within. Yeah, okay, so we need it for this. Do we, though? I don't think we do. I think we can simplify this a little bit. Yeah, so I don't feel like we need this here or here. We need this here because we're setting the state saying, hey, this is the active world. But for these two, I don't think we need it. All right, so here, if we don't have out world, that's going to be a fail. K physics world creates requires a valid pointer to out world. Return false. And this is user code, so I have to make it, you know, able to handle these kind of things. Return true. Okay, so the only thing we'll need to do, at least for right now, is set gravity. We're going to have more of this to do afterwards, but I think for right now, that's all we need to do. So we can just say outworld gravity equals gravity. And I just realized we have a name for this, and we're not taking in a name, so we need a kname name. We need that here as well. Okay. So we'll do outworld name equals name. And again, the name here really doesn't matter, but we are going to want to query the physics world for objects by name eventually, which we don't have that in here yet. Maybe I should add that so that we can start thinking about how we want to actually do that. I'm thinking probably just a binary search tree by name is going to be enough. I don't suspect that's going to be done a whole lot. All right, so, destroy. This should be void. All right, so if world. And then we don't have anything to do yet, but we will eventually. Because we're essentially going to want to go through and destroy all of the bodies that are in there. So actually, you know what? Let's do that real quick. We're going to do within the world, K physics body. And we're going to say bodies. Right? And this is going to be a D array. Right? So we're not going to have to keep a separate count. We're just going to use our D array for that because we're going to be constantly, adding and removing things. I kind of feel like that should be an array of pointers, the bodies. Should it though? Yeah, I think it's gonna. I think I'm gonna do that because technically we could have two different worlds using the same. Do I want to go down that route? Think about it. All right, so I guess what we'll do is here if world bodies exists, D-array destroy world bodies. Right, and then we'll just do K0 memory, size of K physics world. Whoops, totally not what I wanted to do. and we need the block, right? So world. Did I get that right? I think. Yes. Okay. All right. So physics set world. So the physics state is going to have a pointer to an active world, right? So I suppose we should probably also initialize some of this stuff here. So we could say k physics world. K actually state active world equals 0, right? We don't really need to set that up there because this should be zeroed out memory, but we're just being explicit, right? So obviously if not state or not world, return false. And we'll put in here k error k physics set world requires valid pointers to state and world dingus. Right? Okay. So return true is going to be here. And all we're going to do is say state active world equals world. And that's going to be all that we require for that. Add body is going to be a little bit more complex. Not a lot. But that's going to be a pointer to... So I think all we have to do... first off, if we don't have world or we don't have body, I'm actually just going to do this. Okay, physics world add body requires valid pointers to state. That's going to be world and body, the dingus. Okay, return true here. And all we're going to do for right now is oh, you know what? We didn't define a remove. So we should probably iterate through the array first and see if there's any free slots, which essentially would be a slot that's set to 0, right? And if there is, we'll just use that. Otherwise, we'll push into the array. So U32 body count, that's actually kind of funny, equals the array length world bodies. And then we'll just do a boomer loop through that. So U32I equals 0, I is less than body count plus I. And then if not world bodies sub I, then we're going to use that. We're going to say world bodies sub I equals body. Return true, right? And now, if we get all the way down here, that means that we did not find a free space, right? So found a free space, use it. Geez, no free space found. Push a new entry, right? So we'll do darray push world bodies body, and then we're done, right? Now, we could. There's actually a couple things we need to do here. So we'll do B8K physics, and we'll say remove body, right? And we still need a pointer to that, right? We can also say KPI K physics body pointer K physics world. K world. Body get by name. Okay, physics world, and then K name. Let's take both of these and slam them in here. All right. A boomer loop? Yeah. A lot of people don't like, I call them boomer loops because of the other languages that I have to program in. People like, for in or for of loops instead of, a standard loop like this, or like a for each or something like that. And everybody's like, oh, don't do it this way. It's the boomer way, but it's generally the fastest way for the most part, especially like in other languages, like using things like for each in JavaScript actually calls a function every single time, which is rubbish. So, but yeah, I wound up calling it boomer loops because people say, well, only boomers do it by index nowadays. And it's like, well, that's not entirely true. Should really use the word dingus in the game somewhere. Oh, guaranteed the word dingus is going to be used in the game somewhere. We can't have this much dingus-oriented programming and not use the word dingus in there somewhere. It is absolutely going to be used. Fear not. I haven't decided exactly how. Maybe on a sign or something, or maybe there's a menu option or a cheat code or something, but rest assured, it will be there. All right. So, remove body. It's basically going to be the same thing. Well, almost the same thing. So this is going to be remove, right? So we still need that. We still need to loop through here. However, we're going to say if these are equal, has to be the same address, right? Then what we're going to do is darray. You know what? Actually, it's a lot simpler than this. Found the match. Right, so we're actually literally just going to set this to 0. And we're done, right? And then here, we can do a k warn, k physics world remove body, body not found in world, nothing to be done, right? And so this will essentially say if we've successfully removed the thing, then we return true, otherwise false. And so remove in this case, we're not going to shrink the array. We don't want to shift indices around or anything like that. All we're going to do is simply mark that that particular slot, its pointer to null, right? And that's all that we're going to do with that. All right, so getting by name. We're going to do this the brute force way for now, but we are going to enhance this with a binary search later. So we need name, and this is going to be physics world body get by name requires a valid pointer to world and a valid k name, you dingus, right? Okay, so we loop through here, and in this case, we want to say if world bodies sub I, first of all, if it exists, and then if world bodies sub I dot name equals name. Then what we're going to do is return world bodies sub I. Otherwise, we're going to do body get by name, body not found in world, nothing to return. This, though, I'm going to set as a trace, right? And we're going to return 0. And so what we're going to do is, instead of, doing a loop like this, we can maybe use a BST for quicker lookups. I don't really think that's going to be an issue, but we shouldn't be looking up stuff by name every frame, right? We should do it once, keep a pointer to it somewhere, and be done with it. Body count sounds like something else. Exactly. Yeah, that's why I was laughing about it a couple minutes ago. Dingus mode Pintus. What tells me it's a boomer loop is the ++I instead of I++. That's true also. This is a bit of a boomer move too, because most people don't do that. Most people don't bother. This used to actually make a difference, but compilers just kind of do it anyways. This is just kind of a habit that has died hard with me. Not died at all, really. Okay. So, physics body create sphere is going to be the next one. So, this is just the creation of the body. It's not adding it to a world. It's not actually initializing any sort of data or anything like that. It's just basically copying some properties over to this guy. And then this can then later be passed on to be added to a world. So all we're really doing is just kind of initializing some properties at this point. So at this point, if we don't have a pointer to out body, a pointer to out body is required. And you know what? Instead of writing the function name all over the place like a dingus, should be doing that. Return false. Okay. Because that way I can actually do, the same. Actually, let me do, before I copy that. Keep hitting the wrong keys. All right, so I can take this same code and drop it here and there. Okay, so the physics body type isn't going to matter now. It will matter later. So what we should do is out body. Crap, I didn't add name to this, did I? Shoot. Need to update that. Okay, so I guess I should add kname first to all of these. That way we have something to identify it by, right? Okay. So out body name equals name, out body, let's see, we should probably do body type. Oh, that should be, body type, which that should be the same thing over here. And here, which means it's also wrong over here. It's a little more descriptive, Never hurts. Okay, so we have body type is that, out body, shape type is going to be type, this is sphere, right? And then out body position equals position, And then radius equals radius. And that should be it for now. So I can actually copy most of this and reuse it. I'm just going to pasta this twice and change what I need to change. So this is going to be rectangle. This one's going to be mesh. And then we have here half extents for that. And this should be half extents. Okay. And that's it for that one. And then this one, triangle count, and out body. I am not going to take that array as is. I think I'm going to allocate new memory. Yeah, I'm going to allocate new memory and then take a copy of it. That way I don't have to worry about if this gets destroyed. So we'll do kalloc type C array, triangle 3D. And the count is going to be triangle count. And then copy type C array, out body tries, source is going to be tries, type is going to be triangle 3D, and count is going to be triangle count. All right. So that's going to do it for that one. So destroy is just going to be a simple switch statement, which is kind of nice. So obviously, if you know what, let's do this. Pointer to body is required. Okay. And then actually, the only thing that really allocates any sort of memory is triangles. So I'm not even going to bother doing a switch for this. I'm just going to say if body shape type equals physics body shape. What did I do? Shape type mesh. There we go. If body tries, and if we have body triangle count, free C array, body tries, triangle 3D, and then body triangle count. Right, and then we can do, actually we don't even need to do anything else except K0 memory, body, size of, physics body. This is a destroy too, so that should probably be, you know what, I'm going to turn this into a warning. Whoops. I'm going to turn this into a warning and then just return. We don't really need a Boolean return value for this. Physics system. Okay. So that's that one. And then position set, rotation set. Okay, so those are all pretty straightforward stuff, I guess. I guess we could just set those up real quickly. So if not body, turn false. And then body position, whoops, equals position, turn true. Why didn't it? Okay. And actually, we're going to do the same thing for rotation. You don't have to use this API for this, right? You could just set it on the body itself. but we may eventually have like dirty flags or something. So maybe if we ever switch to handles also, this is going to be the way we're going to want to do it. All right, so apply impulse is the only other thing, but we do not have anything there yet to handle that. So all we're going to do is put a to do in here. Implement this and return true. Actually, we're just going to return false at this point. Because we're not doing anything right. So if we call it, we should probably, I suppose we could assert on it too, but okay. So this all looks pretty good, I think, so far. So now we got to start thinking about how we want to actually handle the physics system updates, right? So more than likely what I'm going to do is probably have like most of the update stuff. I know a lot of the times I tend to like have, you know, these private static functions that I then declare at the bottom of the file. I don't know if I want to do that this time around though. I guess I should probably stick to the pattern. All right, I'm going to define it here and move it later. All right, so we want physics step is going to be the first thing, right? So we want k physics, system state, and then we want F32 delta time, right? And so we'll obviously have to know how much time has passed every time we take a step, right? And so essentially what we're going to do, and I'm not convinced that this is going to be the way. In fact, I know this is going to be the way. Not going to be the way I'm going to do it long term. What we're going to do now is we're going to take that number that we had in our configuration, and we're going to divide our frame time by that number, and that's how many steps we're going to take for that particular frame. Eventually, what needs to happen? This needs to be on its own thread, running on its own time cycle at its own update interval, right? But we don't have that yet. We're going to have to actually put that in. But I don't think we need that to actually get this running at a basic level. So, so what I'm going to do is, let's do F32. Step delta is going to be frame time divided by state config steps per frame, right? And speaking of which, if we don't have config, steps per frame is going to equal to 10, right? We want to set some reasonable defaults, right? Okay, so we'll do the step data, and then we will, again, do the old boomer loop. I equals 0, I is less than state config steps per frame plus I, and then we'll do if not physics step state, and then we're going to want step delta. Then we're going to do k error failed to apply physics step, see logs for details. Right, and we'll return false. Okay. I feel like I'm missing something. I probably am. That's okay. All right. So in each individual physics step, we are always going to return true for right now because we check the state and stuff here, right? Oh, you know what? If state and frame time, right? We don't want a non-zero frame time. Frame time should be greater than 0. Oh, so that would be if it's less than or equal to 0, that's a problem. Okay. So our delta time is going to affect everything. The very first thing that we're going to look at is our velocity. So we're going to do vector 3 step velocity is equal to vec3 multiply scalar. And we want the state config. Wait, didn't we have... Oh, what a dingus. I haven't set up the actual active world yet. Okay. So, in fact, we don't, if we do not have an active world. I guess if we have an active world, then we do this stuff. Otherwise, we don't. Right? Okay. So state active world, gravity. We're going to take that and multiply that by our delta time. And so that's essentially going to give us what, that should be gravity. That's going to essentially give us what the gravity application should be for this particular step. We did set that, okay. So that's going to be the first thing that we always want to apply is we want to say to every body that's there, we want to go ahead and apply gravity to it first before we do anything else. So what we'll do is we'll say U32 body count, DRA length, states, active world, bodies. Stop typing quotes. I don't want quotes. I want semicolon. There we go. All right. For U32, I equals 0, I is less than body count plus I. All right. And so for this, the first thing that we're going to do is apply that gravity, right? So that's just going to be, let's see, should we add that to, I guess we should probably add it to the velocity. But only if it's a dynamic body. So let's do K physics body equals address of, or actually it doesn't even have to be address of because it's already a pointer. State active world bodies sub I. And so first off, if there's a body at all, right? And then if inside of that we have the body type is dynamic, then we want to do this, right? So we only want to affect dynamic bodies. Okay. So the first thing we're going to do there is just do a simple body velocity equals vec3 add body velocity and then step gravity, right, which has already been scaled to that time step. Okay, so apply gravity first, and then comes the other thing that we need to talk about. So typically with physics systems in general, you've got what you call broad phase, and then what you have called narrow phase, right? And broad phase is basically just all of the objects against all the other objects in the world, and the narrow phase is sort of the individual object types colliding with one another, right? So broad phase is basically to say, hey, are there any objects in the world that are within range of where they could collide with one another, potentially? And then the narrow phase would say, okay, well, what kinds of objects are there? What shapes are they? And let's take those two shapes and let's see if they collide using a specific function to check between those two particular shapes. And so our broad phase we're probably just not going to do initially until we actually have a some sort of spatial partitioning, I'm thinking. So I think I'm just going to skip that for right now, and I'm just going to iterate through all objects. And I'm only going to be checking or updating dynamic ones, right? So I'll go through and check all of the dynamic objects against all other objects in the scene. But I won't go through and check static objects against all other objects in the scene, right? Because they don't get affected by anything. So we only need to loop through dynamic objects for the check, and then for the thing that it checks against, we'll have to loop through everything, if that makes sense. I started using ++i instead of I++ recently. I guess I'm a boomer now. Congratulations and welcome to the club. Thought about switching to handles for my asset manager refactor, but I like automatically that's the automatic. Wait. The automacity? Automacity? Is that a word? Automacity? That seems like it shouldn't be a word, but maybe it is. But I get what you mean. That smart point is provided as a word. Okay, I've just never seen it used, I guess. My dyslexia kicked in hardcore there, by the way. I know what it means from context, but I've just never seen it written out, I guess. I've never heard anybody say it either, actually. That's very funny. Yeah, I mean, the thing about pointers, though, and the reason I'm a little bit on the fence about using pointers for things like this instead of handles is because if you have an array of objects that aren't pointers or structures that aren't pointers, for example, like this is if we just had this, right? And our physics bodies were owned by this array, right? And I got pointers to something in this array instead of using a handle. Then if I had to expand this array by reallocating it, the address of all those things would change and those pointers would become invalid. So that's not great, right? Which is also kind of the reason I don't really want to do this. And I think I'm probably going to switch away from that now that I'm thinking about it. So the reason I came up with handles to begin with was kind of to avoid that problem, right? Now, I'm getting away with it here because I'm keeping an array of pointers, right? So here in this situation, that kind of works, right? But if it's ever not an array of pointers, that's a problem, right? So I don't know. I'm a little bit on the fence. I do prefer handles. It's just pointers are a level of indirection, so are handles. So it's just choosing one, right? But pointers are Pointers are a little bit faster than handles, only slightly, just because you don't also have the stale check that I do for handles. But I mean, it's a quick number comparison, so it's not really that much faster, but it's certainly not something that's going to completely tank performance, right? Why is Twitch bleating about my bitrate? should be. I don't think I can change it while I'm live anyways, but yeah, I literally have it set to automatic. So I don't know why Twitch is complaining. All right, well, what is the size of your handle? So that's another thing, right? It's just intrusive ref counting. Not really, because it's not ref counting. It could be used for ref counting, but the handle system itself isn't ref counting. Oh, okay. I see what you mean. Okay. What's the size of the handle? So I can go. It is bigger than a pointer. So there is that, right? So it is a U32, and then this identifier, which internally has a U64. And this is, you know, a unique identifier that's generated via CRC. And then this right here is just the handle into the resource, some sort of resource array generally. So it is bigger than pointer, right? I could theoretically change this to 32 bits and then it would be the same size, but yeah, it's not all that large. I've actually considered changing the unique ID in there to 32 bits because I don't think I need 64-bit uniqueness there, but because all that's really used for is to check to see if it's stale or not. It's not twice as large though. It's like 1.5 times the size. Right. Well, okay. It is in this case because this is a 64-bit machine, right? So 64-bit environment that I'm on. So the size of a pointer is 8 bytes, and then you have the 4 bytes for the U32. So it's like 1.5. Alignment would make it twice, yeah, but I don't bother aligning them. Yeah. But that is another reason I'm thinking about like reducing it to 32 bits. Yeah. 4 bytes of padding. Yeah. I really don't want to change that now, but now you guys are making me want to change it. You're not wrong. I don't know. It's automatically aligned. Yeah. Yeah. I mean, when you're thinking about it that way, yes. Okay. Where was I? Okay. Do we have... So we get rid of that. I'm just trying to make sure we clean up after everything that we're doing. I think we do. Except that's fine. We'll come back to that. Okay. So I think it's literally just a matter of actually figuring out now what we need to do for this. So there's a few types of interactions that we can have. If we go back to here, so I'm going to just define some functions here, and then we'll kind of implement them one by one. Or maybe... Maybe I'll do it in one function with a huge switch statement and call it a day. Okay, so let's do... I guess we'll do... What do I want to call this? Collide bodies, I guess. So what we're going to do is we want a k-physics body, body 0, and k-physics body, body 1. And then I guess we technically need 2 switch statements, but that feels kind of, well, maybe it's okay. All right. Switch. So we're going to check body zeros first, right? And we want the shape type is what we're going to go by, right? And then so we will fill this out. So I guess within each one of these, we're going to have to check the body 1 type. I guess I could just do it this way. I guess it feels a little bit weird to do it this way, but right? And then we populate this one too. And then by the time we get in here, we know exactly what we're dealing with, right? So here is like sphere to sphere, or sphere to rectangle, or sphere to mesh, right? Rectangle. Because I assume these are probably going to get large enough at some point. I'm not going to be able to easily discern. Sphere to mesh, right? And technically speaking, collide bodies, the first collide body is always going to be dynamic, right? The first body should always be dynamic. And then the second can be either dynamic or static. So technically that means dynamic dynamic mesh shapes are not supported. And this we can return false. All right. So I think this is the only thing that we're not going to support for now. I think when we're checking from these other types, that should be fine. So I actually need a copy of this. We'll probably wind up switching or splitting this into different functions, but for now. Okay. I would keep using only a 64-bit handle and using 48 bits for addressing and 16 bits for metadata, kind of like what processors do with addresses anyways. Neutral on that, it might depend on use case. Yeah, I could do something like that, I suppose. Because really, I guess for the... Technically speaking, the resource index really only needs to be 16 bits, right? Like if I have an array of am I really going to have an array of over 65,000 resources for anything? Like maybe at that point, just don't do that. I don't know. That seems... I don't know. I have to think about it. I think I'm probably overthinking it at this point. Okay. So what we need here is we need to essentially do the collision detection, figure out how far they intersect to one another, and like what angle they intersect and how far, if they do at all. And then resolve based off of that, right? So the first and easiest thing to check, obviously, is we could just look at the radii for both of these and see if they collide together, right? And that's really all that it requires. So essentially what we can do is if body 0 radius plus body 1 radius is, I guess it's going to be, if those two are greater than vec3 distance. I might want to use the squared one there for performance reasons, actually. Yeah, let me do that, actually. Let me do this. Body 0 radius times body 0 radius plus body 1 radius times body 1 radius. Oops. Because doing these two multiplications, then adding them together is going to be faster than calling square root to get the non-squared version of the distance. Okay, so I can do a check at this point to say if that is less than the distance between body 0 position and body 1 position. Have a collision. Right? And actually, we should probably take the... We should probably save that result. So let's actually split this up because that's kind of hard to read anyway. So we'll do F32 body 0 radius squared is equal to this. And then what? Is it bleaching about what is it complaining about? Let's do this one. I'm going to add these things anyways. I normally do. All right. So we have that. And we'll do body 1 radius squared. And then we'll do I guess we could actually just do F32 distance squared equals this. All right, so if the two radii are greater than the distance between, then we have a collision. So what we can do is get what do we want to call that? The penetration amount, essentially. So we're going to say the penetration amount is the body radius 0 squared plus body radius 1 squared minus distance squared. So that's going to be the amount. And then the vec3 direction of that is going to be vec3 sub. And I guess we'll do body 1. Oops. Position. And body 0 position. And we should probably normalize that. All right. So now if we have a collision, we have the penetration and the direction, right? So now we need to resolve, right? So the resolution for this is going to be pretty simple. For now, we're not taking into account mass, right? So that would add a little tiny bit of complexity to it. But all we need to do here is, if we have two spheres that are colliding, if they're both dynamic, we're going to split the reaction between the two of them. If only one of them is dynamic and the other is static, then we are going to apply all of the correction to the dynamic one, right? So if body 0 body type equals body type dynamic, and body 0 body type, oops, body 1 body type equals K physics body type dynamic, split the correction between the two of them, right? Let's see. This won't compile without a local scope. Yeah. I usually add these by default anyways. I don't know why I didn't, but yeah. Because it's going to bleat about all this other stuff going on here. So I should scope all these while I'm at it. I usually do by default. I just didn't for some reason this time. I'll worry about the spacing and tabbing in just a second. Okay. Let's see. How much is penetration related to body count? I know. I'm thinking as I'm writing these, I'm like, these are technically the terms, right? But why though? You're not wrong. It depends on body radius. Yeah, exactly. I'm trying not to crack up like a 12-year-old while writing this. I have a question for you. If you want to become a game programmer, specifically gameplay at a AA AAA studio, do you think it's better to build a portfolio of games in a commercial engine or a portfolio of simple games made with something like DirectX or Vulkan? That highly depends on the studio you're going for, and the position you're going for, right? So if you're wanting to do gameplay, I would say probably stick to an existing engine that's common, like Unreal or Unity or something like that. I would probably go more Unreal these days, simply because DirectX and Vulkan are usually handled by people that want to do engine dev, not necessarily just gameplay, right? Those are two completely different things and are commonly split in studios. The studio I worked at was combined, but that's because it was a very small studio. But yeah, more often than not, especially if you're talking double or triple A, definitely, I would say use an existing commercial engine. Now, that being said, it is not a bad idea in your spare time to do a project in DirectX or Vulkan or even OpenGL, just to get a better understanding of how that stuff works under the hood. So that way, when you run into issues with the engine or you're trying to work stuff out in the engine, you actually know what's going on under the hood. So I would still recommend doing it, but just change your thoughts behind how and why you're doing it, I guess. Just wondering why if studios preferred seeing low-level work as some proof of raw programming ability. Again, it depends on the studio. Whatever studios you're looking at, try to find out what tech they use. The raw programming ability will probably apply more to studios that use their own tech, right? That use their own game engines, rather than a studio that uses an out-of-the-box engine. It's not absolute one direction or the other, but like I said, it highly depends on where you're applying. I hope that makes sense. Ooh, I just realized what time it is. Crap. I do have to get up in the morning, so I am going to have to end. I guess let me figure this out real quick, and then we'll look for somebody to raid. Okay, so, or at least I can leave myself some notes, right? So, else if body 0 body type equals k physics body type dynamic, right? And then else if again but for body 1. Right, so we can say here, issue all of the correction to body 0. And then in this case, we're going to issue all of the correction to body 1. And that's basically how that's the layout of how we're gonna handle it across the board, right? So in this case, we want to do, let's see, do we want to apply that? We should probably apply that to, we haven't taken into account velocity yet, actually, which actually has to happen before this. Okay, so let me put something up here. I guess, so to do, apply body 0, velocity scaled first. And then here, I think we're going to want to move the position and then also scale the velocity based off of what we do here. So I think we'll pick that up on the next stream, actually. Because like I said, I am pretty much out of time for tonight. So we will definitely pick this up on the next stream. And we'll get into some more of this other stuff like handling rectangles against meshes and stuff like that. All right. Let me check for somebody to raid. And while I do, for all of you new viewers who have just joined us tonight, thank you very much. And if you haven't followed already, I would greatly appreciate if you did. Because I am trying to grow the channel, and that helps. Every little bit helps. And I already see who we're going to raid. So, Els Dragoon is writing 6502 assembly for an NES game. We're going to go and raid them before they have a chance to raid us. So we're going to kick that off. And yeah, I will see you guys next time. So thanks for joining. And yep, see ya.